Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Stickier Notes by James Sinclair. And I did sticky notes a couple days ago, or I guess in the release of videos, it'd probably be a couple days or maybe like a week um for you guys since you saw the sticky notes version. This is the upgraded version. The previous one was 6 by 6. This is 7 by 7, which is why they are stickier. Anyways, let's get to the rules. We have, and this is by James Sinclair. Don't know if I said that. Let's get to the rules. We need to divide the grid into 7 orthogonally connected 7-cell regions and place the digits 1 through 7 once in each row, column, and region. What is an orthogonally connected region? So it has to be basically all cells in that region can go to any other cell in the region just by going through edges, all while staying within the region. So this would be an example of a valid orthogonally connected region. Because to get from this cell to this cell, you can just go through edges, all while staying within the region. This would be an invalid version of the region, because even though these two cells can get to each other by going through edges while staying within the region, they cannot go to the rest of the cells by going through edges, all while staying within the region. They would have to go through a corner, or they would have to exit the region, which is not allowed on an orthogonally connected region. So that's an example of how orthogonally connected regions work. Each region has a corresponding color. A note outside the grid indicates that the region of that color contains a run of one or more orthogonally connected cells bounded on either side by a region border or the edge of the grid in that row or column. The number in the note, if given, is the sum of the digits in these cells. If a region contains multiple sets of orthogonally connected cells in the same row or column, a note only applies to one of them. And when notes overlap, the note above has a lower sum than the note below. And this applies even if a sum is hidden or not given. So what's an example of this? So in row 2, we are guaranteed one of the regions that is orthogonally connected, which means just they share an edge. So these are not orthogonally connected regions. We know one of these has to have a green, and it would have to have a 6 in it. This has cells that says that the run of green regions must have a sum of 6 also. So this is the sum. Assuming this is the green region, then this would have to be 1, 2, and 3 to add up to 6. We also know there would have to be a red and a yellow orthogonally connected sum. That yellow would have to be greater than 6, and then red would have to be greater than the yellow sum. Anyways, this would have to have 6 as a sum somewhere as a green set, so this would have to be 6 there if that were the case. And we'd have to have red as a set, which would have to be greater than 6. So you could have, I don't know, red doing something funky like this, I guess. And then you could have yellow going like that. And this would work. So you could have yellow being like, I don't know, 4 and 6, and then the red being 5 and 7. That could potentially work, or something along those lines, right? So in column 5, we have the greens adding up to 6. a yellow as a set adding up, that adds up to 10, and the red as a set adds up to 12, which is greater than the yellow set, which is greater than the 6 of the greens, right? And then this could be something like, I don't know, 4 and 3, and that could work. Because we have 6 as a set, which adds up to 6, and then red as a set, which adds up to something greater than 6. So remember, the note applies to only one subset, only one of the sets of orthogonally connected cells in a row. It does not apply to multiple ones. And again, if you have overlap, the note that's the lower sum is the highest one possible. So that means this is green, which is less than the sum of yellow, which is less than the sum of red here. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. We have gray going from row 6 to row 1. That means it must have 6 cells there. And it's also in column 7. So it can only be... So in row 1, its sum must be greater than 8. And since we have only the digits 1 through 7 in each row, that means there are 2 digits in the gray section. So this must be one of them. And it has to have a gray section there. And then it's either 5 cells here or 5 cells here. And this must add up to at least 9. So it's 2 through 7 here. This digit, well, we don't know. We could have 6 digits here. Or 6 digits here. Interesting. Blue, well, we only have 2 there. So we have only 1 digit in column 3 for the blue. Blue has to go across 5 rows. It cannot be, obviously, all 5 rows here. It has to have 2 digits in row 1. Because, again, it adds up to 8. We don't have any other restrictions, really. Red goes across 4 columns, so we have 3 cells left. Oh, it goes across 4 columns and 4 rows. So it must be some, like, shape like this. Or it could be like this. So this, it has to go red here. Because you have rows going here and rows going here. So it must go across 4 rows and it must go across 4 columns, which leaves there are no extraneous cells for red. And this has to be greater than 7, so there's at least 2 here. But if we go 2 here, it has to be all 4, right? You can't go... Well, technically you could go across there. Interesting. Here we have red greater than 6. Here we have red greater than 6. So one of these must have red going in this direction. At least in 2 cells, because you cannot both be 7s. Blue again goes across 5. Yellow doesn't have that much of a issue. So light has to go 6 here or 6 here. If light is 6 here, this must be orange, because this has to go out as that. Otherwise, you could have gray going here and then orange going here, and this is 3. Oh, wait, no. If gray goes here, yeah, this has to be all one region, and it's never adding up to 3. So gray has to go this way. So gray is here, this is orange, and it goes out, and this must be 3. This cannot be 3 here. So this is boundary here. Ooh. Boundary. Why? I said edge only now. Weird. Okay. This is boundary. Let's draw a border around the entire... orange has to go somewhere here. We're not sure which. Gray here is a singleton digit, which is greater than blue. Okay. Green goes across 4 here, but goes across 3 here. So we have one extraneous cell left in green. So green has to go across here. How many digits do we have then? We have 16 cells here. 7 are accounted for by red. 6 are accounted for by green. But we don't have anything else. We do know orange goes eventually up to here. That's fine. It's greater than gray. Yellow here has to have at least 2 cells, because it's greater than red, which is greater than 6, so that's at least 8. Again, this has to be 9. 8. So blue has 2 cells here at least. And it must go 5 down. But it could just be 2 and 5 that way. That seems fine. Oh. Interesting. So what the blue is going to be... If we try to have the 2 go there... Obviously, you can't have all 5 blues there. I guess he could still go across, though. Well, the thing... Right, so this only means one of them, right? It doesn't say it can be multiple, right? So we know... Okay, so 3 cannot be here, therefore this is 3. And so this adds up to at least 9. So this is 6 or 7, which means the remaining digits in this box are 1, 2, 4, 5, 6, 7 as possibilities. This digit is greater than a blue digit, so this can't be 1. We don't know how many of oranges are here. If we try... Okay, so we are guaranteed 5 blue cells going from column 1, or row 1 to row 5. I guess you could do something funky like that, right? That is possible. But the problem with that, or you could do something funky like this. Well, that doesn't work either. I guess you could do... Well, Um. Hmm. Hmm. That is kind of interesting. Again, green, red. Well, red is definitely 7 cells within this 4x4 box, right? Because it must extend out to here and then out to here. So it could do something funky like that, right? But it has to all stay within the box. Green is also somewhat restricted. It also has to go through here down to here. So 6 of the cells have to be there in the box. I mean, can it be outside? No, because you have to go 3 outside, and then that's too many, right? This is 1, 2, 3, 4, 5, 6, 7. Can't reach here. So it has to have 6 within this box, which means that's 13 cells accounted for in this 4x4 box. So blue cannot have more than 3 cells in this box. Um, I mean, it could have 0 if it's this way, right? Otherwise, if we try to have a 2 here, I mean, we could. It's problematic, though. So say we... Okay. You can't have 4. Let's try to have 4 and show what happens there. So say we have, like, 5... something like this. That's not gonna work. Okay. This is problematic because 2 and 6 add up to 8, and then you can't have a 6 here by itself. Even this is going to be a little funky. Green and red would both have to be here. And that's gonna be... There's no way red can reach. Green has to reach here, which is possible, but then can't reach there. And red has to reach here, which means that. So this can't ever be blue that way. But you can't have well, you could have multiple blues, do something like that, maybe. The problem is this is 2 and 6, and then they would have 6 there, right? So you have to either have 3 blues here and 1 blue here, or the 2 is doing something funky here in one of these 4 cells. But then, like, how does that work, right? You can go blue, blue there, then there. 1, 2, 3, 4, 5, 6, 7, right? But then you have green and red here. The problem is green outside here doesn't work. Yeah, so this is just problematic. But you could have blue doing something like that, which is completely outside of this 4x4 box. And then that works. You cannot have these be non-green or red. If you have green here and red here, or red and green, you have one there and one there. This can at most go this way. And then this can't cover. So therefore, that's why you have to have... Red is the same problem, right? Red can't reach all the way there with 7 cells. So you have to have 7 red cells here. Which means red and green cannot be here. Red and green... Red has to be in one of these 4. Guaranteed. Green has to be... we don't know. We could go extend 1 each this way. So I'm trying to figure out possibilities of how that would work. So say we had blue trying to do something. Oh, that doesn't work. That's an orthogonal connected region. You could do something like that maybe, but then this has to go around, and then you have the same problem, right? Maybe you could do something like this. This is problematic because red and green both have to be here, right? So you can't do 4 here. Can you even do 3? Is sort of what I'm thinking. You can't reach there. 1, 2, 3, 4, 5, 6, 7. You would have to do something funky like that, but then the red and green would have to go around, which doesn't work. You can only have 1 blue here. I think it has to be that scenario. I mean, maybe you could do something like this. That could work too, actually. Let's say you don't have blue there. How do you connect? You're gonna have problems all the time, right? Blue has to reach down all the way here. And it cannot do in this 4x4 box because it takes too many cells. So I think that guarantees blue cannot... You can't reach this far down, right? It has to be at most 2 away, so it can't get to here. So in this 4x4 box, we have 13 cells accounted for. So blue cannot take more than 3. Yellow could do something funky like this. No, because that's part of the 4x4. Huh. So what happens... So I think then blue has to be either this... So this is basically all blue. And you have 2 extend there or 2 extend there. What happens if we have 2 extend there? This has to have red and yellow. Red can only be part of these. So say we have red and then yellow here. Yellow has to be at least 2. This is 7. This is potentially possible. This would be 4 cells in the 4x4 box, or 3 cells accounted for in the 4x4 box. So this must be red and green. The problem, though, is we only have 1 more green cell here, and then this can't form a valid region. You could have yellow doing something like this. That's fine. So that's fine, but this doesn't form a region by itself. What if we had yellow here and red here? And this is not going to be greater than the red, because the red has to be 7. So that doesn't work. So this doesn't work at all, so this has to go this way then. Which means this is 2. This is 1, 5 as a pair to add up to 8. That makes this 3, 4, 5, 6. This is 7. 3, 4, 7 here. This has to be less than the gray, so it can't be 7 there. This is greater than green and yellow, but we don't know which those are. So this is done. green, yellow. Pink has to be part of this. Orange. So green, red, and yellow have to contain... This can't be green. This can't be red. This is green or yellow. Not yellow, red. Green or yellow. Red can only be in this spot. So we have red here. Green can go one outside of this boundary. So green has to be there. And therefore, one of these is yellow. I mean, yellow could technically be here. Yellow must reach 5 down, at least. This could be all orange, technically. So that's fine, also. So this could be orange. There's only 3 yellows in this area. This 4x4 area. But technically, yellow could be in... We can't go 4 there. Because then it has too many. So this can't be yellow here. Yellow could technically be 3 that way, 4, 5, 6, 7. No, it can't. It must reach down to here. So yellow could get potentially these parts. It cannot extend to here. Because, well, I mean, technically it could. Oh, in fact, it actually has to extend to there. Ooh. These could technically be green here, and these could technically be green here. We have pink and orange. Red cannot extend past this. Green cannot extend past this. Yellow technically could go down to here. Could technically go here. Okay. This is 1, 2, this is 13 cells, which red and green cannot be part of. The reason why yellow could be here is you could have something like this, right? Actually, well, Well, we know yellow's one of these two. The problem with yellow being that is that's too... Yeah, so this can't be yellow, actually, either. One of these is yellow. Could be both. This can't be orange. If this is orange, that would be... It has to be all 7 oranges there. So this has to be pink. This can't be orange for... It can't reach, so this is pink. So these are both pink. 1, 2, 3, 4, 5, 6, 7. The problem is that's not enough pinks. So this can't be orange. It's pink there. You could have 6 there and then 1. Could just have oranges all the way there. So that's fine too. Can you have 7 here? That would force all 7 there, and therefore green and red would have problems. So no, this can't be all yellow. You could go, what, potentially 1, 2, 3, 4, 5, 6, 7. So can you ever go 6 here? No, because green and red can't get there. So this can't be yellow either. Can you ever go this way? The answer is no. Right? Because if you try to go yellow here, that's too many cells, part of that 16 cells there. You could have extensions, though. Maybe you could have something like that. Can you ever go here, though? Maybe. Yeah, that seems okay-ish. Except that it takes too many cells here. This has to have yellow, red, and green. Red has definitely had 2 here. Yellow could have 1 or 2, and green has 1 or 2. Green cannot be 2. If green is 2 here, yellow, or no, yellow could be 1. That could work, actually. Never mind. Can this actually ever be green? I don't think so, right? Then yellow has to do something funky like that, and then green's trapped. So this can't really be green. Can this be orange? If this is orange, that's all orange. Yellow is going to be stuck here. And 2, 3, 4, 5, 6. This is too many cells. So orange cannot be here. Yellow has to be here. It cannot go around here because that would block that cell from being something else. So this must be yellow there to connect. This has to be yellow because if it's not yellow, that's green. But then the green's going to be something funky. The yellow would have to go here, and that would be blocking that. So this could be green or yellow. We're not sure which. If this is orange, yellow would have to go 1, 2, 3, 4, 5, 6, 7. That's 4 cells in that 16, which is impossible. So this cannot be orange. Can this be green? Then it would also require yellow to be in this set, and that would be too many. So this can't be green, that's yellow. This could be orange, though. No, because it's 1, 2, 3. Well, it could be 1, 2, 3, 4, 5, 6, 7. That is possible. Or 6, 7. No, it has to go down to here. So we have 1, 2, 3, 4, 5, 6, 7. But the problem is then this doesn't have green or red. So this has to be yellow then also. That means this is 14 cells which require pink and orange. So this has to be then orange. This cannot be yellow here. We have 1, 2, 3, 4, 5, and maybe 6. 1, 2, 3, 4, 5. It has to get down to here, so that must be then here. Because these are too large, so yellow cannot be here. That doesn't work. We don't have enough reds and greens. Orange could go up here, and so could pink. Oh, okay, never mind. So then yellow does have to go down here. We have one of, so this is 6 then. Because there's no other way. It can't go that way because then we don't have red and green here, right? Red has to be 2. Green has to be 1 then. So this is red and green. We cannot, this is red and green. Red has to be connected, so this is not green, this is red. And it has to be 2 cells here. Huh. I mean, yellow could technically go here, too. Yellow can't go any of these. Can only extend 1 more. We have one yellow here. Hmm. Technically, orange could go one more here. Orange or pink. Well, okay. 1, 2, 3, 4, 5, 6, 7. So this can't be orange. Pink could go up to here. Orange could go... It can't go in any of these. 1, 2, 3, 4, 5, 6, 7. So orange can go to there. Okay. Blue is less than medium, which is less than yellow, but these can't be yellow. So this has to be, this can't be 2. Can't be 7. This is 5, 6, or 7 there. Green is less than yellow, which is less than blue. Okay. Blue is less than red, which is less than yellow. Oh, yellow has to have 2 here, so this cannot... Ooh. That's a problem. So how does that work? Yellow has to have 2 here. Red has to have 2 here. I guess green could be here. But then that makes that yellow, right? Green. 1, 2, 3, 4, 5, 6, 7. No, this could be green. So if we try to have yellow... Okay, this can't... Okay. So this is going to have to be then... Green, green. I think. And then extend that way. Or extend that way, or extend that way. So we have 2 greens. We have to extend to here. It cannot cut off there, so this can't be... I mean, it could be green if it goes this way. We don't have to have yellow there, then. Interesting. Okay, so that's... my coloring was all off, then. That's not great. Red definitely has to be here. Seven. Yeah, we still have the same issue. But, okay, so if we try to have yellow, this is problematic because we need 2 yellows here. So if we try to have yellow, 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 3, 4, 5, 6, 7. The problem is you cannot have green and 2 reds here, which we need 2 reds here. So this cannot be yellow. Since this can't be yellow, that's green, which means that's green. We need multiple yellows. Oof. 1, 2, 3. So pink can get to technically here. So pink can get to any of these. Yellow can get to 1, 2, 3, 4, 5, 6, 7. Any of these. This can't be pink though. Okay. This is 2 greens. So it needs to reach here. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7. So it has to do something to reach here. So that means there's no more greens outside of the lines that we had. So this is green. This is green. It could be 3 greens here, 1, 2, and 3. That is potentially possible. We need a red here also. Um, hmm. Hmm. So this needs to be multiple yellows, which means this has to be yellow. Yellow cannot reach here. If we try to have yellow here, it's just too many cells, right? Well, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's too many cells. So yellow cannot be there. If it goes there, it has to extend that way. So because of that, I mean, I guess yellow could go down to here because it doesn't have to be one of those two. Hmm. One of these is green. So if we have yellow here, how does green work? If we have yellow here, yellow has to sort of, I don't even know. It would block green. So this can't be yellow. So this is green or red. Um, you could have green doing that, which would mean this is 1, 2, and 3. This would be 6. You'd have 4, 5, or 7 there. Remaining digits in row. Oh, that's interesting. 4, 6, and 7 with a guaranteed 4. Um, hmm. Um, Pink cannot get all the way here. That's 4 cells in this 4x4, which we know we can't have. Same with, well, it could technically do here. Well, this has to have red and green. So if we have green, if this is green all the way here, this would be red. So say we had red here. The problem is green has to connect to this. And that's not possible. Because that would force red to be a 4-cell region. So if this were red, green has to connect this way. So that's not possible. So this can't be red. That's green. If this is red, we have the same problem. We have to go around, and that would block red off from being there. So that's green, which means this can't be red. Same thing. So this is green. So we have 5 green here. We have to get 2 to here. So this cannot be green anymore. This is red or yellow. So green has to go 2 here, or 2 here, or 2 here. So this is guaranteed to be 1, 2, and 3, which means that no 1, 2, and 3 in the rest of the row. So it's 4, 5, 6, 7. This is only 6 by itself, so that's 6, which means this can't be 6 here. That leaves that as not 6. This is 7, which makes that 4. So no 7 here. Yellow is greater than red. Or sorry, yellow is greater than green, red is greater than both. So we have 2 green, 2 reds. If this is 2 greens, oh, this has to be red. So this is red. Which makes this yellow or orange. Red has to go out, so this has to go out that way. If we have 2 greens, 4 reds have to go that way. which is going to block that off. So this cannot be greens. What about green here? We have the same issue. 1, 2, 3, 4, 5, 6, 7. This T would not be part of a region. So green does have to be these. So those are green. Which makes this a 5, 7 pair. Eliminates 5 and 7 in the rest of the column. So that's 1, that's 5. Red has to get to here, so this is red, which must connect to here, so that's red. If we have anything in between, that's going to block this, so this must be all red. Same here. So we have 1, 2, 3, 4, 5, 6, 7. So that's all the reds. Red cannot be here anymore. That means this is yellow. No 6 here because of 6 in the column. This has to be greater than 6. No 1 here, no 2 here. Red is less than green, which it assuredly is here. Green is less than red, so this cannot be 3. So this has to be, this is 4 and 1. This would have to be 6 or 7 here. Blue is less than medium, so that can't be 2, which is less than yellow. So this has to have yellow. So this can't be orange. This, therefore, is yellow. So yellow, yellow, yellow has to get out. 4, 5, 6, 7 would block off orange, so this can't be yellow that way. 1, 2, 3, 4, 5, 6, 7 can't even reach there. So that's this has to be multiple yellows. So this must be yellow here. That's 5 yellows. Cannot be yellow here and yellow here because that would block that cell, so this can't be yellow there. Okay, so we have 1, 5, 2, 5, which is less than 10. 8 and 10. Green here is less than red. It's 1, 2, 3, so this must be 7. So we have 7 here, which makes this 4, 3, and 7, which makes this 5 and 7 there, which means this can't be 7, that's 6. This is greater than green, so this is 1, 3, and 2. No 4, 7 here, no 4 here, it's 5 and 6. No 6 here because of 6 in the row. So 2, 3, 1, 7's greater. So this is done. This is done. We have blue, medium, and yellow. And this has to be greater than medium. So this is 5, that's 4, which makes this a 1, 2 pair. This can't be 2 because of 2 in the column, so that's 1, that's 2. We have green, which is less than yellow, which is less than blue. 5 means this has to be 6, which makes that 5. This must add up to 6 because it's between 5 and 7. So this is 2, 4 as a pair. This can't be 2 because of 2 in the column, so this is 4, that's 2. This cannot be yellow. Actually, this could have been 1, 2, 3. Okay, no 4, 5 here. No 6 here. Remaining digits here. Remaining digits in red are 3, 4, and 5. This can't be 3, so therefore 3 is here. This can't be 5, so that's 4, which makes this 3, or not 3, 5. Therefore, this has to be 1, 2, 3. And the yellow must add up to 6 that way. So this is yellow. And this is 1, 2, 3. Which means this can't be 1 or 2. It's 6. No 6 here. Yellow. So this is 5 yellows. It has to have 2 yellows here. So this cannot be yellow here. We need a 7. And we have to have... It has to be greater than 3 and 5. It could be 2, 7. but this is part of the yellow. And it can't be 2 or 7, no 3, 5, 6. It can't be 1, because 1 and 7 only add up to 8, and we only have 2 yellows here. So this has to be 4 then. And 7's one of these. 1, 2, or 7. 1, 2, or 7. No 1 here because of 1 in the column. No 1 here. No 2. No 3 here. So remaining digits in column 1 are 1, 2. Column 2 are 4, 6. Column 3 are 6, 7. Column 4, 2, 3, 5, 7. No 3 here. And column 5, 1, 3, 5. Column 6, 1, 2, 4, 7. So pink needs access to a 3. So it must get to one of these two. This is not 3. So that means pink has to go this way. So no orange, no orange. And then it can get to there. So it's 5. This cannot have 2 here. So again, 8, 10 is greater than 8. We have 6, 7 is greater than 6. 3, 4, and 5. So medium gray, yellow. Blue, green is 5. These add up to 6, and then blue is 7. 6, 8. And we have 11 here for the yellow. We have pink here. We have orange here and medium. Green, red is 3, and green is much greater than 3. 2 is blue there. 5 is green, and red is 6, which is greater than 5. 6. This has to be 7, because it's 3, 4, which means this can't be 3. So 3 needs access to... Pink needs access to a 3. This is 3, which makes this 2, which makes this 1. So no more 1 here. No 2 here. This is 7. This is 2, 7 as a pair, which forces this to be 1, which makes that 2. This is 2. Yellow has to go here. So this can't be yellow here. It's orange, which means this can't be 2. We have 2, 4, 7, 3 as part of orange. We have 5 here. It could only go 2 pinks there. If it goes pink there, one of these is not going to have a region, so this cannot be pink. This can't be pink for the same reasoning. 4, 7 is going to be greater than 2. So we have 6 and 7 is greater than that. So yellow's done. Red is greater than that as 9. 3, and then we have everything else for gray. No 7. 2 and 7 eliminate 2 and 7 here, so it's 5, which makes that 3, which makes this 1 and 5. This cannot be orange because we have 2 5s in the orange then. 1 eliminates 1 here, so this is 2, that's 1. We have a guaranteed 6 here. So this is 5 cells. This cannot be pink. This is orange. No 4, 7, so this is 6. And this can't be orange. It's pink. We are done as borders. 6 eliminates 6 here, so it's 7. That's 4, 7, 6, and 4. Yeah, interesting. It's interesting how these interact with each other. What was interesting particularly was this part, right? I thought yellow had to be here, but I guess not. It basically forced green to be there. Because if we tried to have yellow, it was because of this scenario, right? This had to be 2 cells here. Because it had to be greater than at least 7, which means there's at least 2 cells there. And I guess similar here, right? It was kind of really restrictive there. And then you had basically, I guess 6 of them weren't here. That's interesting. Huh. It was only 5 in that area. That was what was hanging me up there. That's why I thought it had to be yellow there. Um, huh. So maybe blue could have. I don't know. I think blue was still problematic, right? I don't think my logic was necessarily good, but I think the general feel of it was right. Because we did have a section where in this 4x4 where you have four of that weren't red or green. So I don't know. We definitely had to have all 7 reds here, but we didn't have to have 6 greens. So I wonder if we could have. I don't know. I feel like that this was the general. Like there was no way that you could have 4. Well, you couldn't have 4. You can't have 4 blues here. You can't have 4 blues here. You can't really have 4 blues here. No, you can't because this requires green, yellow, and red. You can't have 4 blues here. Yeah, so it's always going to be problematic, right? Um, hmm. You can't have 2 blues and 1 blue here. So you have to have at least 2 here and 2 here, or 3 here and 1 here, which is going to necessarily require 5 in a row. Right, and then if you have 5 in a row here, red and green can't be on this. Red can't be here, so that's going to be problematic. You can't have 5 down here because you only have 1 blue, and it would be 2. You can't have 5 here because, again, red has to be somewhere here. So it's basically the red that's restricting things, which means blue has to be here. But we tried this blue, and that didn't work. It just doesn't work because this has to add up to 8. Yeah, so basically it's the red that's restricting things here for the blue. We did eventually actually force orange, pink, well, but... Yeah, green needed to get here. That's the issue, and that restricted things a lot. So the green section logic was incorrect. There weren't that many restrictions on the green in this 4x4 box. It was really the red had to be restricted to this 4x4 box though, and therefore that eliminated blue as possibilities in each of these columns, right? And blue cannot have 2 here and 1 here. It has to either have 3 here and 1 here, or 2 here and 2 here, because of the numbers that we have. So therefore, because of that, it has to be 5 straight down, which means you couldn't do any weird shenanigans of like that, something like that. Because this would be 6 and 2, this would be 6 here, and that would be a problem. Interesting. Yeah, some of my logic wasn't very solid, was actually incorrect. But I think the general gist of it was correct. And yeah. That was kind of tough. Not sure. I mean, I'm curious about what the stickiest notes are gonna be like, but it seems like that would be kind of hard too. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.